This time we're going to look at the diffraction grating formula, similar to the young slits formula, and see why we don't need to have an approximation there. So this is our grating over here, and this is our screen over here. And what we are basically saying, like we said with young slits, is that there's going to be an angle at which, when we shine the laser through our diffraction grating, there's going to be a point of light right in the middle, and then there's going to be another point of light. Using 300 slits, 300 lines per millimeter, and the wavelength is about 600 nanometers, and if your distance to your projection screen is about 3 meters, then this is going to be about 70 centimeters. So it's reasonably big. And there's going to be nothing in between, but there's going to be another laser point there. And we're asking, why is that happening? Remembering that our grating is really quite small. This picture doesn't give us relevance. But what we find is that there is an angle which all these photons coming through, if you like, the slits, are all going to be 1, see that, 1, to the second one, 2, to the third one, 3. Each line you go down from each slit, obviously there's a lot more photons going through each slit than one, but each line you go down, each gap you go down, is one wavelength difference. So at this angle, all these guys are in phase. So at that angle, if you look down that angle, you're going to see the light. And so therefore, if you put a screen there, you're going to see a bright dot on the screen. Now, if we look at this here, and we go, okay, got it. It's like that. We've got this angle at which this happens. Try and make sure it's reasonably parallel. And what we are saying is, as usual, D, in fact this time it's like 5D or whatever, is going to be equal to 5 wavelengths, or D is equal to, or D times the sine of theta is going to be equal to n wavelengths for constructive interference, which is what we got up there. Now it doesn't matter about the fact that once we get up here, we're saying they've travelled a different path difference, and if you look down this way, you're going to see the bright light. If you project them on the screen, it's not like, because we've rotated the screen a little bit, that we're going to end up them cancelling out. They don't cancel out. At this angle, they're constructively interfering. 1 wavelength difference between each slit, causing constructive interference. This formula, therefore, is not an approximation. Alright, we did not have to approximate that formula. D sine theta truly is equal to n wavelengths, because that is D sine theta.